This video focuses on the product line engineering. To be able to establish the product lines, the seamless integration between Chess tool and BVR tool is achieved. The base variability resolution language defines variability orthogonally for any meta-object facility-compliant model representing the base model. The generation of target configurations is performed with variability or VSpec, resolution, and realization. The Chess tool is built on top of Eclipse Papyrus to enforce working with different views, requirement, system, component, deployment, analysis and PSM views. The attitude and orbit control subsystem is modeled in the Chess tool. The hardware components modeling and their allocation to software is performed in the deployment view. The software functional modules are modeled in the component view. They are classified into 5 groups: sensor processing, estimation, guidance, control and command distribution. For variable attitude and orbit control subsystem, there are different combinations of sensors and actuators, as well as the associated software functional modules. The constituents tend to be same when used in different variants. The BVR tool has also been integrated in the AMASS bundle. The option for creating a new BVR model can be located under the example EMF model creation wizards. After giving a name and selection of model object, the Finish button is pressed. This creates a BVR model. It can be opened with VSpec, resolution and realization editors. The VSpec editor permits variability engineers to create VSpec models, which are an evolution of the feature-oriented domain analysis, usually called feature models. The mandatory features are connected to the parent feature via solid lines, whereas the dashed lines represent optionality. The constraint-based resolution is also incorporated, for which the logical operators such as implication, alternative, negation might be used. For example, the constraint sun sensor implies magnetometer and not star tracker enforces the inclusion of magnetometer with sun sensor and exclusion of star tracker. Valid tailoring is thus guaranteed if the constraints are properly specified. The resolution models are automatically generated from the VSpec model, but the choices needed to be included or excluded. This is done for the execution of associated variation points. The validation process is executed to confirm whether the resolution corresponds to the VSpec model. For the variable attitude and orbit control subsystem, 4 resolutions are defined. Realization is based on the fragment substitutions. A fragment has a placement and replacement. The replacements and placements are highlighted in blue and red colors, respectively. The execution of a fragment removes the placement elements and substitutes them with the replacement elements. To create the placements and replacements, the elements are dragged and dropped on the realization editor and then create placement or create replacement option is selected. The star tracker, thrusters, STTH, resolution is executed. The tailored models are automatically exported back to the desired locations. The generated attitude and orbit control subsystem variant can be visualized in the Chess editor. As the safety management embraces both processes and products, which due to, for example, products upgrade, tend to be tailored, giving rise to safety-oriented product lines and corresponding safety-oriented process lines. The process and product lines would be integrated. Many thanks for your attention.